Good morning. We are continuing with Unit 3, doing CO22. I can find the prime factors of a number using prime factorization. Big name. But we're going to be working with those prime numbers that we talked about yesterday. Those numbers that we can't break down any farther. It's just itself and 1. That's the only factors to get those numbers. So we're going to break down numbers to all of their primes. So we're going to simplify it using prime factorization. So first thing we're going to look at, DNA. Does anybody know what DNA is? Different subject. What is it, Aiden?
Stuff from like your parents, just like it's like in your like they say you.
So it's in your body. It's your genes. Okay, it's what makes you you. Your DNA you do get from your parents, right? It gets passed down, and everybody has their own unique DNA. So DNA is a person's genetic code. We get it from our genes. What makes them who they are? So your genes are what make up you. What is special about you? Why would we be defining a science term like DNA in math class? So if DNA makes up who a person is, what does that have to do with what I talked about with those prime factors, James?
Because numbers have like roots to get to them.
Yeah, the numbers have their roots, those prime factors that make up that number. So the numbers have their own genetic code that make them unique too. This code is the number's prime factors. So prime factors are the prime numbers that multiply to make a given number. So if we have a big number and we can break it down to its primes, we can say this number is made up of these prime factors. So we're breaking it down to its number code. You can use a factor tree to find the prime factors of a number. We're going to learn what that looks like. Multiply the prime factors and your product should be the original number. Write the prime factor. So we're going to learn how to do that. So let's take a number, like let's say the number 10. What two factors can I multiply together to get 10? Melina?
5 and 2.
5 and 2. Can I break 5 down any farther? No, 5 is a prime number. Can I break the 2 down any farther? No, 2 is a prime number. So my factors for 10 are 5 times 2. 5 times 2 equals 10. So that's its number code. It's its factor code. Like our DNA code, that genetic code. Yeah. And Melina just realized we're making it like a tree. We're going to keep going down till we can't go down any farther. That's why we call it that factor tree. We're going down, and it kind of looks like a pine tree as we're going to be getting bigger and bigger. With the bigger numbers, they have more factors to them. So let's look at number 12. what two factors could I break that into? Isabel?
4 and 3.
4 and 3. Is that the only factors I could have broken it into, Nora? 6 and 2. So let's see if it matters which factor pair we start with. We're going to see if we get the same answer. So let's start with that 4 and 3. Can I break 4 down any farther? What can I break it into, Amelia?
2.
I can break it into 2 and 2. We don't want to just say 2 because we have to multiply it by something. So 4 can be broken into 2 times 2. Can I break my 3 into anything? No, 3 is a prime. So I'm just going to bring it down and rewrite it. So see how it's looking like a bigger pine tree? And I need you writing. Can we break our 2's down any farther? No, 2's are prime. Okay, the only factors of 2 are 2 and 1. So we're down to all of our prime numbers. So it's 2 times 2 times 3. Those are our factors. So let's look at the 6 and 2 factor buddies that we used. Let's see if we get the same numbers. Can I break my 6 down any farther? Aiden?
Yes. 3 times 2.
3 and 2. Can I break my 2 down any farther?
No.
Nope. So I just bring my 2 down. 3 is a prime, 2 is a prime, 2 is a prime. So look at that. I have the same numbers. I like to organize mine from the smallest number to the biggest. Same set of factors. So I use different factor buddies and I get the same answer. So it doesn't matter which set of factor buddies you use, you'll still get the same answer. You only have to do it with one set of factor buddies. Then it says, write at least 3 factor pairs if applicable. So we could say, what would be a factor pair? Factor buddies. What is a set of factor buddies for 12? 4 and 3. What is another set of factor buddies, Olivia? 6 and 2. What's another set of factor buddies, James?
12 and 1.
12 and 1. So for any number, you have your first set of factor buddies, the number times 1. So that's your first set of factor buddies right there, is going to be the number times 1. Then you have to look at what other factor buddies you can find in it. James?
Are we going to use the pine tree method?
Yes.
Okay.
So I want you practicing this because as we get to the bigger numbers, it's going to help you. So for every single one, you're going to make your pine tree. It's almost as if we're getting ready for the Christmas season. So you're going to, it is not, it is Thanksgiving season. Oh, okay, so Mr. Gambino has his alarm clock set to the Christmas music station. So every morning I'm waking up to Christmas music and I say, but it's not Thanksgiving yet.
Yes, but Christmas isn't all around the season.
Okay. Love truly. We are still recording, so that was a fun little sidetrack for my friends at home. So, what you need to do is you're going to break down your composite number into all the way down to its prime factors. Luciana?
So we only have to do like one tree.
Yeah, let's do one more example, and this is all you have to do. You only have to do one set of factor buddies, one pine tree, one factor tree. Okay, Melina?
Do we have to do like the 2 times 2 times 3?
Yes, that is the factor. So it says write the prime factors of each number. That's what this is. Okay, so if we were to multiply 2 times 2 times 3, if you put that into your calculator, you get 12. So yep, so this and this You have two answers that you're putting. You're putting down the factors that you multiply together, and you're putting down your factor buddies. Isabel.
What if it like only has like their own part? Like it's only the two things.
Like up here?
Yeah.
Then that's it. This. And then it says, if applicable, you're going to put 3 factor pairs. So we would put 5 and 2, 10 and 1. There's only 2 factor pairs for this one. So that's all you're going to put. So you'd have 5 times 2, and then 2 sets of factor buddies. So let's do one more together. Let's do 27. What factor buddy could I start with? Riziki. 9 and 3. Can I break my 9 down any farther? Taya. 3 times 3. Can I break my 3 down any farther? Nope, so I'm going to bring that down. So look at what my prime factors are going to look like. 3 times 3 times 3. I'm going to circle that because that's my answer. Those are my factors, my prime factors. 3 times 3 times 3. Can anyone think of a different way I could write 3 times 3 times 3? This is from an objective a while ago. Thea? 3 to the 3rd power. Okay? Either way would work. 3 times 3 times 3 is the same as saying 3 to the 3rd power. So over here, 2 times 2 times 3, I could really say 2 to the 2nd power times 3. Okay, if you're more comfortable writing it all out, that is fine. If you're ready to go, oh, I remember those exponents from quite a few objectives ago. I remember that. I want to do the exponents. You can. Either way is correct. Am I done answering this question? What am I missing, Olivia? I need to write my factor buddies. So what are my factor buddies for 27? Riziki? 9 and 3. What one does everyone have a factor buddy with?
1.
1 and what, Isabel? 1, and you go back up to your original number. 1 and 27. Do I have any other factor buddies for 27? No, I only have 2 sets of factor buddies for 27.
Okay.
So that's your final answer. You would have your prime factors, either 3 times 3 times 3, or 3 cubed, 3 to the 3rd power. And then you have your factor buddies, 9 and 3, 1 and 27. Melina.
We did 2 trees on number 12.
You only have to do 1 tree. I was showing you for the 12 that it doesn't matter which factor buddies you start with, we end with the same answer. But you only have to start with 1 factor buddy. You don't have to give all the factor trees that you can. You only have to do 1. Doesn't matter if you start with 1 factor pair and your buddy next to you starts with a different factor pair. You're going to end up with the same answer. James.
So you say on the 9 of 27, you do the 9 and 3, and then below it, do you just write 127?
So you do your factors, your prime factors, 3 times 3 times 3, right? And then you do your pairs, 9 and 3, 1 and 27. Any other questions? You guys are having great questions. It is fun because math is fun. I do enjoy math. All right, for my friends at home, we hope you are well, and we hope to see you soon. Have a wonderful day.